How's it going? Today we're going to be doing problems from lesson 11, 12, and 13. And we're going to start off with lesson 11. So, we're going to start off with question number 2 from lesson 11, which is asking us to find the y prime using differentiation for the equation x cubed minus xy plus y squared. So, first, we're going to find the derivatives of the original equation. So we're going to get 3x squared minus bracket derivative respect to x times y plus 2y derivative y equals 0. So now we're going to develop this part of the equation. So we're still going to have 3x squared minus, now we're going to use the product rule. The derivative first multiplied by the second plus the first multiplied by the derivative of the second. Brackets plus 2y derivative y over derivative x equals 0. So now we continue to evaluate the equation. So you get 3x squared minus 1 times y plus dy over dx parentheses x plus 2y equals 0. Now we gotta separate the equation. So you get 3x squared minus y equals minus dy over dx parentheses x plus 2y. And now we also have to get dy over dx back on that side. Dy over dx is equal to negative 3x squared minus y over x plus 2y. So the y prime by implicit differentiation will be equal to negative 3x squared minus y over x plus 2y. And that is how you solve it. Next, we are going to find the value of the derivative of the function f of x equals x squared over x squared plus 4 at its relative minimum of 0, 0. So first, we have to find the derivative of our function, and for this we're going to be using the quotient rule. So we are going to be doing the derivative of the numerator multiplied by the denominator minus the numerator multiplied by the derivative of the denominator, which would be 2x, over the denominator squared. So we continue to break this down. We distribute 2x, we get 2x cubed plus 8x. We distribute or we multiply x squared plus 2 times 2x, which will get us negative 2x cubed over x squared plus 4 to the power of 2, which would equal 8x, these cancel each other out, over x squared plus 4 to the power of 2. Now, we have to find what does f prime equal when x is equal to 0. So, we input our 0 for our x's, and we get 0 over 16, which equals 0. So, what we found out? We found out that the slope at this point is equal to 0. It is a horizontal line. the slope is a horizontal line at that point. Alright, next up, we're going to be doing question 1 from lesson 13, which asks, identify the open intervals on which the function f of x equal x squared minus 2x minus 8 is increasing or decreasing. So, first we have to find the derivative and set it equal to 0. So, derivative of this equation is going to be 2x minus 2. And to find what we are looking for, we're going to set this to greater than 0. Because if f prime of x is greater than 0, f of x will be increasing, and if f prime of x is less than 0, f of x will be decreasing. Now, if we take our 2 across, 2x greater than 2, so this means that we need x to be greater than 1 in order for it to be increasing, and we need x to be less than 1 for it to be decreasing. So at the point 1 comma infinity, our function will be increasing. And at the point negative infinity comma 1, our point will be decreasing. So now we draw it out. We draw our x-axis. So here we have our point 1. Our line coming up this way is going to represent the open interval 1 comma infinity, and this is increasing all the way to the right. And our line over here coming from this way, from the left, is always going to be decreasing. This line right here represents the open interval negative infinity comma 1. So the two open intervals that represent the increasing and decreasing in this equation will be increase 1 comma infinity and decrease negative infinity comma 1, with the point 1 right here, or more specifically 0 comma 1, representing the minimum. I'm sorry, not 0 comma 1. 1 comma 0 is representing the minimum point of this equation. Thank you. Finally, we're going to be solving a question from lesson 14, which asks, determine the open intervals on which the function f of x equal x squared minus x minus 2 is concaved upwards or downwards. So first we have to find the first derivative, which is 2x minus 1. And now we have to find the second derivative, which will be equal to 2. Now, we know if the second derivative is greater than 0, then the graph always will concave upward. Always up. If it is positive, it is over 0. So 2 is greater than 0. So now we know that our graph is always going to concave upward. And this is represented by the open interval negative infinity, comma, infinity. So at all points, it will be concaving upward.